Howdy guys, in this video we're going to take a look at how to find trig functions without a triangle. In the last video we looked at trig functions on a coordinate, not trig functions, we just looked at angles on a coordinate grid. But how do we find trig functions if an angle is more than 90 or less than 0? If it's acute between 0 and 90 we could do a triangle and we'd be set to go. But what about when I have an angle that's bigger or less than that? So let's just think about this. Imagine we have an angle. You see this purple angle here, and I've put it on the coordinate grid. This angle is theta. Looks like it's more than 270 but less than 360, so maybe 300 degrees or so, 315, somewhere in that range, 310. Doesn't matter. But you'll notice what I did is I added a circle to this picture. So I just added this circle. It could be any size circle. But if we look at this circle, we see this circle has a radius. This radius is from here to here. Okay. And then this point has an x and y value. X is going to be the distance here. And y is going to be the distance here. Can you imagine? Okay, so this isn't, don't forget, this is an xy coordinate grid, right? And so we could think of this as being a coordinate grid where there's x values and y values, right? Okay, so this x coordinate here is this distance, and this y coordinate is this y distance here. I'm going to get rid of all that extra tick marks because I don't want to be distracted by them. But if we're doing this, we can then do trig functions. Basically, we just define, instead of terms of a triangle, we do it in terms of x, y, and r. And so you see here, sine is the y value over the radius. The y value over the radius. So even though the sine of 310 is going to be y over r, you can see if we look at the reference angle of this triangle here, that it is the opposite side of this triangle over the radius. But be careful, it's not just the opposite side of the triangle, it's the y coordinate, which means in this case y is negative. R, though, my radius, always positive. It's a distance. So cosine then is the x-coordinate over the radius. Tangent is the y-coordinate over the x-coordinate. And so that is just another definition that you need to add. So we have SOHCAHTOA. We have those definitions that we can use. We now have sine, cosine, and tangent in terms of x, y, and r. And those are important, that you're comfortable with those. So let me ask you another question. What's the reciprocal of sine? Hopefully you're remembering we need a co, and it's not cotangent because that goes with tangent, so it's cosecant of theta equals y over r. I asked that because what's the definition of cosecant? Well, if we take a look here, we can see cosecant is going to be r over y. Secant is r over x, just the reciprocal. Cotangent is the reciprocal of tangent, x over y. All right, so now it asks to find the 6 trig functions for this picture. Well, you look at this picture, you can see we have an angle theta. We can see my initial ray is here, or initial side, my terminal side is here. You can see this is my x-coordinate here. This distance is -4. My y-coordinate, this distance, is -3. Okay, and so we're now going to find sine theta, cosine theta, tangent theta, and then the reciprocals, cosecant theta, secant theta, cotangent theta. Now you'll notice we don't have r. That's a bit of a problem, isn't it? We need to know r. I bet if you pause it and think a minute, you can come up with a way of finding r. Hopefully you're thinking Pythagorean theorem. Pythagorean theorem would work great here. 3 squared plus 4 squared equals r squared. If you know your Pythagorean triples, this ends up being 5. So r is 5. And now it's just a matter of using our definition. Sine is y, negative 3 over 5. Cosine is x over r, negative 4 over 5. Tangent's y over x, negative 3 over negative 4. That gives me positive 3/4. And then the reciprocals. Cosecant is 5 over negative 3. Secant is 5 over negative 4. Cotangent is going to be positive 4/3. Let me know if you have any questions on this. But that is essentially how we do trig functions without a triangle. Now you might say, well, wait, we had a triangle. Technically we didn't. Technically we had y values, x values, y values, and a radius. Y over r, x over r, y over x. And we just use these definitions to help us. Now, I'm not saying don't use a triangle to help you remember, but really remember these are coordinates, so they can be negative. Radius, though, the radius is always